All right, let's dive into a really big architectural shift in how GitLab CI/CD gets things done. We're talking about a fundamental move away from a system that's constantly begging for work to one that's smart enough to direct it where it needs to go.
You know that feeling, right? When a system is just constantly checking for work over and over again? It feels inefficient because it is. That constant, "are we there yet?" isn't just annoying. It's a huge drain on resources and a real bottleneck for performance. We're about to solve that.
So here's our game plan. First, we're going to break down the core problem with the old way, which is called polling. Then we'll introduce the awesome new solution, the job router. We'll get into the secret sauce that makes it so smart, look at the careful 3-phase rollout, and then, most importantly, we'll talk about why this whole thing is going to make your life better.
Okay, so let's set the stage. To really get why the new way is so good, we have to understand how GitLab runners have traditionally found jobs to run. This has been the foundation of GitLab CI for years.
This slide really nails the fundamental shift. It's all about moving from a pull model to a push model. The old way, polling, is pull. Imagine thousands of runners all yelling at GitLab every 3 seconds. "Got a job for me? How about now? Anything yet?" It's noisy, it's chaotic, it's inefficient. The new way is push. A central router just calmly tells the right runner, "Hey you, I've got a job for you." It's the difference between chaos and control.
And that old, chaotic way has real consequences. That little delay before a job gets picked up, that's latency. It means your pipelines start slower. All those millions of empty requests, that's just wasted CPU cycles, which means wasted money. And if you're trying to scale to thousands of runners, forget about it. The polling itself becomes the bottleneck that chokes the whole system.
Okay, so enough about the problem. Let's talk about the solution. This is where we get to see how we're building a much more intelligent, much more efficient architecture for the future.
So, meet the hero of our story, the KAS job router. KAS stands for GitLab Agent Server, and you can just think of it as the new brain of the operation. It's the air traffic controller for CI jobs. Instead of runners calling in all the time, they now open up one single, long-lasting connection. It's a gRPC tunnel if you're curious, and they just listen. They wait for instructions from KAS.
So you might be wondering, okay, that's cool, but how does this air traffic controller know which runner is the right one for a specific job? I mean, in a big company, you could have thousands of them. Well, the magic behind all of this is a concept called a capability fingerprint.
This is just a brilliant idea. A capability fingerprint is basically a unique ID, but it's not for a single runner. It's an ID for a type of runner. So any runners that are configured exactly the same way, same tags, same access levels, they all share the exact same fingerprint. This lets KAS stop worrying about thousands of individuals and start managing them as just a handful of logical groups.
So what actually goes into making one of these fingerprints? Well, it's a hash of 4 key things. First, the runner's tags, like Docker or production. Second, its type. Is it a group runner, instance runner, and so on. Third, its security status. Can it run jobs from protected branches? And finally, which projects can it actually see? If all 4 of those things match between 2 runners, boom, they're identical twins as far as KAS is concerned.
And this is why fingerprinting is the linchpin. It unlocks so much more than just job matching. You can now do incredibly smart things. You can calculate the exact demand for a specific type of runner, which makes your autoscaling way more precise. You could even prioritize cheaper runners within the same pool. It just opens up a whole new level of intelligent fleet management.
Now, change this big is obviously pretty risky, so GitLab isn't just flipping a giant switch overnight. Instead, this is being rolled out as a deliberate, 3-phase evolution, with each phase building safely on the one before it.
And here's that journey. It starts simple in phase 1, just acting as a smart proxy. Then in phase 2, it gets a lot smarter by coordinating auto-scaling. And then finally, in phase 3, it reaches its final form as a fully orchestrated push-based system where KAS is the central command.
Let's break down phase 1. In this stage, KAS just acts like a smart proxy. Runners stop pulling GitLab directly. Instead, they open that gRPC connection to KAS, and KAS does the polling for them. This is a huge win right off the bat, because you go from thousands of connections hitting GitLab down to just one. It immediately cuts down the noise and load.
All right, now in phase 2, things get a lot smarter. Now we start using those capability fingerprints. KAS can look at the job queue and say,
Hey, I have 50 jobs that need the Docker production fingerprint, but I only have 10 runners online. Time to scale up. This is so much more precise than the old way of scaling.
And finally, phase 3. This is the end game. Polling is completely dead and gone. Now GitLab proactively pushes new jobs to KAS the second they become available. KAS is now the one and only source of truth for job assignment, and it uses a super sophisticated engine to make the absolute best routing decision every time.
So we've talked a lot about RPC, fingerprints, and orchestration. But what does all this technical stuff actually mean for you, day to day, running your pipelines? Let's break down the real-world benefits.
I mean, this table pretty much says it all. We're going from a system that has built-in delays and is incredibly wasteful to one that's instantaneous and efficient. Just look at that efficiency row. We go from wasted CPU on empty polls to runners are truly idle until a job is assigned. That one change has a massive positive impact on performance, cost, and scalability. So, to wrap it all up, what's in it for you? Well, first, your pipelines are going to start faster, period. No more polling delay. Second, your auto-scaling will be way more responsive, which means you're not paying for idle machines. Third, that translates directly to lower costs and smaller cloud bills. And finally, this new architecture is totally future-proof. It opens the door for awesome advanced features down the road, like routing jobs based on cost.
And that's really the final thought here. This new architecture isn't just about fixing old problems, it's about creating a brand new platform for innovation. By totally removing the bottleneck of job scheduling, it opens up a whole new world of possibilities. So the real question is, with a system this smart, what will you optimize next?